Hopefully we recall the Pythagorean theorem from days of old. Just as a quick formal restating, Pythagorean theorem says 4 right triangles. We'll draw a little right triangle here. It says 4 right triangles. For right triangles, the following expression holds. It says that a squared equals c squared. Or the sum of the legs of a right triangle, recall, are the sides that make up the right angle. So A and B are legs, where A, B are legs, and C is the hypotenuse, or the side that's opposite of the right angle. The hypotenuse in a right triangle is always the longest side, as well as another piece of trivia. Okay. A squared plus B squared equals C squared. Pretty famous theorem in mathematics, named after a guy, Pythagoras. He was the leader of a cult. You'll get to learn more about that after the quiz. That'll be part of your little one story. Kind of cool. Yeah, they actually killed people over this stuff. It's pretty neat. Anywho, Pythagorean theorem comes up a lot. We're going to use this. It's kind of like our building block, our building block fact of mathematics here. That we're going to use whenever we encounter right triangles. It's always something you can use to try to find missing side lengths. Specifically, if say I gave you say a ramp here, and I said that the ramp is 125 meters long and it extends outward 120 inches here. How high up do you actually get with this ramp? Is kind of a quick application of the Pythagorean theorem. And that we have a right triangle created here. And we know that the longest side, 125, is like our C, it's the hypotenuse. So if I take 125 and square it, that's the same as if I square each of these two smaller parts. That's the same as h squared plus 120 squared. Okay. Note that one thing we're not going to do is just square root everything. That's really not feasible here. That's pretty bad algebra move. What we do want to do is isolate what's being squared here, this h, and go from there. So if I square these two things, I get 125 squared, 125 squared. Oh, what did I say last time?
15,625.
What is it? 15,625?
Yeah.
H squared, don't know what that is yet, but I do know 120 squared is 144 with 2 zeros. I'll finish solving this. Subtract the 14400 from both sides. And get, what, 1225 is h squared. Now that we have what's being squared isolated, I can square root both sides. H is 35. There is a unit associated with this. What's the unit?
Inches.
This inches. Just a length. So this ramp actually raises up off the ground 35 inches, or just shy of 3 feet. Okay. Quick application of Pythagorean theorem. We can do it again as well. If I want to find the area of an isosceles triangle, we recall that the area formula is for any triangle is 1/2 its base times its height. Note the height is simply just any altitude of the right triangle, or whatever triangle you want, just an altitude, and then the base is whatever side that altitude is trying to intersect. In this case, we have that drawn in. We have an altitude here, h, and we have this side length of 14. So that implies that our base here is going to be 14, which is good. We have 1. Unfortunately, we don't know what the height is. So we're going to have to argue what the height is and figure out what it's going to be. Does anyone want to take a shot in the dark as far as what it's going to be? Go from there, Joel? Okay. I like what you're going to do, but I want to make sure that we understand why this has to be so. How do we know that this is being intersected? How do we know this is being bisected to begin with? What's forcing it, Steve?
Well, because the two side lengths on the right and left are 10 to the
Okay, so it's isosceles. So what does that mean? This triangle's isosceles. What does that tell us? Okay.
The thing we learned last was like if the two are equal when they meet at the top, then the two sides, the bottom, have to be equal to each other because it like.
Did we have? Yeah, we have the base angles theorem. So we know that these angles, if this isosceles, we do know that these two angles are the same measure, for sure.
No, I mean the two lengths of the.
I don't think we had a theorem that says something like exactly like this. I think we can argue it. I believe it's possible to argue it's going to be true, but I want to make sure we're thinking about how we're going to do it. Dimitri, what's something you need to do?
You have a triangle.
Excuse me, Dimitri, he's talking.
You have a triangle, and then it goes from the point or the top part of it, and it goes straight down a 90-degree angle. You can see there on the line. You know that that's the what's it called?
I don't. We didn't have anything that specifically says that this has to be a perpendicular bisector, right? It's. I mean, we'd like to argue that it is, because if we can argue this is a perpendicular bisector, then we're good. Then this is definitely cut in half. But how do we know that? Just because it's right angle doesn't mean it's a perpendicular bisector. This is by definition an altitude. Travis,
Well, you can prove the two triangles are congruent.
how would you do that?
Side,
What would you do?
side angle, side.
Side angle, side. Let's see two angles. And this is the only side we really know. Wait, this, you could use, like, I think hypotenuse leg is pretty much given, because you have a reflexive side, the hypotenuse, and then it's a right triangle. So for sure you can use hypotenuse leg. I think there are other ways to do it too, Kate.
Converse of the perpendicular bisector theorem. If a point is equidistant from the arch point to the segment, then it is on the bisector of the segment.
How do we know that these two? How do we know that these 2 points are equidistant?
Because
This is forced to be a perpendicular bisector. We can argue that either with the converse perpendicular bisector theorem, by arguing with the triangle congruence idea, that they're the same. There are many ways to show, but the key idea is that you actually need to show it. We don't know where this actually intersects without some background like knowledge, without some arguing why it's true. If I just gave you a triangle and drew an altitude, as we're going to see in section 7.3, just because I draw an altitude doesn't mean that it bisects the side. By any means does it mean it just bisects. You better understand why it's bisected. Okay? There are a lot of ways to show it. We talked about a couple of them. But regardless, once we know that it's bisected, we know that these two things have to be the same length, which forces each piece to be, how long? Is it 7, right? So we're actually going to force to get 2 triangles that are essentially this. Okay.
at this point, because of what I just said, the whole converse of the perpendicular bisector, wouldn't any isosceles triangle, if it's perpendicular, wouldn't they always be?
The altitude drawn from the vertex.
Yeah,
is gonna be
it would always
perpendicular.
be a perpendicular.
From this argument that this is a perpendicular bisector, we know that each of these segments has to be the same length, namely 7 in this case. So if we know this is 7, this is 10, now we can use the Pythagorean theorem to figure out what h is going to be. So we can set that up. We know that the longest side hypotenuse has got to be opposite the right angle, which is 10 here. So we know 10 squared is equal to h squared plus 7 squared. Or 100 equals h squared plus 49. H squared is 51. In exact form, h is the square root of 51. As a approximated decimal, this will be, well, what, 7 point, what did we say? 1.4 or so. We approximate to the hundredths place. Root 51 is approximately 7.14. Now that you know h, now you know v, we can calculate the area. So we can plug in half times. Therefore, the area, half times 14 times 7.14, which gives us an area of approximately 49.98, I believe. What's the unit that's associated with this answer? Inches squared, what are we doing? Inches squared is an area. Areas are square units. So 49.98 square units, or inches squared. Okay, we're going to see, the next part is kind of an extension of this. So we know that for right triangles, the Pythagorean theorem holds. The converse is actually also true. So the Pythagorean theorem is more or less an if and only statement. So if we know a relationship amongst the sides of a triangle, then we can actually claim like what type of triangle it's going to be. So specifically, converse of the Pythagorean theorem is as follows. It simply says that for any triangle, if this actually holds, if a squared plus b squared does equal c squared, then the triangle is a right triangle. Regardless, if I ask you to tell me whether or not it's a right triangle, let's try to fit these numbers into Pythagorean theorem. Note that the hypotenuse of a right triangle is always the longest side. So if I give you three numbers, we're not just picking the last of them to be c, we're picking the largest number. So find the largest value and make that c. In this case, 10. In this case, 10 is our largest value. So we're setting up Pythagorean theorem, we'll say 6 squared plus 8 squared is that 10 squared. Is, if we add the sum of the squares of the two smallest, is that equal to the square of the largest? Well, let's see, 6 squared is 36, 8 squared is 64. Is 36 plus 64 equal to 100? Yeah, both sides are the same. Since both sides are equal, since a squared plus b squared equals c squared, then yes, this is a right triangle. On your own, quickly check the next two. 1 squared plus 5 squared, we're checking, is this equal to square root of 26? Squared. Square root squared, these are inverse operations. By definition, we're saying root 26 is what number times itself is 26. Well, if I multiply that number times itself, I better get 26. That's by definition, the square root and the square. So I better get, say, 1 plus 5 squared is 25. Is that 26? Yeah, indeed it is. If you try to use a calculator here and use decimals, you're going to get the wrong answer. If you use exact form, you'll get the correct answer. And yes, this is the right triangle. Okay. Due to our highly formal argument via math aerobics, Pythagorean inequalities are as follows. If c squared is bigger than a squared plus b squared, then we argued that the triangle is obtuse. And also we argued that if c squared is less than a squared plus b squared, then the triangle is acute. Note that the triangle inequality must always hold. So I guarantee you at some point, whether in the homework, in a quiz, or a test, I will try to trick you and give you 3 arbitrary numbers that don't fit a triangle. Make sure you're checking to make sure that the numbers, the values, actually make a triangle. Once you know they're a triangle, then we can argue what type of triangle it's going to be, okay, via that same argument. So we'll check Pythagorean theorem. If it's equal, we get a right triangle. If c squared is bigger, then we get an obtuse triangle. And if c squared is less than the sum of the legs, then it's an acute triangle. Okay. I'll check the first one with you. You'll check the last two on your own. So we'll see. C has always got to be the largest value. So we're gonna pick out the largest value in this triple. We'll make that our value of C. In this case, 16 squared. We'll check 16 squared versus 8 squared plus 15 squared. 16 squared is 256. 8 squared is 64. 15 squared is 225. And compare that to 289. What kind of triangle is this? Well, first of all, which one of these is bigger?
Let's think about it.
I hope 289 is bigger than 256. Which forces this, which forces this, which means what kind of triangle is this?
Cube.
It's a cube. The sum of the legs is greater than the square of the hypotenuse. C squared is less than a squared plus b squared. Therefore, this must be the acute case. Use the same argument to check B and C. And that'll be the last thing we do.